Hello, my name is Zuhai, and today we're going to talk about process coordination. So, what it is actually it ensuring multiple process work together smoothly without data inconsistency. So, why does it matter? Because if a process try to access the same data at the same time, it can errors can happen. An error can occur. So, an error like deadlock. I am going to explain that log shortly. So the solution is by having the data, having the process synchronized with each other. So synchronization keeps data consistent and prevent conflict between process. So it have to be synchronized, it have to be the same at the same time. Process must happen at the same time, not process access the same data at the same time? No, but a process access another data but at the same time. So that is the synchronization. So what race condition and need for synchronization? So no, sorry. We are going to talk about race condition and need for synchronization. Race condition is when multiple process modify data stem simultaneously causing unpredictable results. So, how synchronization helps is by ensuring that the process access data in a controlled manner. Just like when I say, like back when I say, all right, more like you have to uh, process access data at the same time, but different data. Okay, okay. So, and it synchronization also use block mechanism to organize process execution, execution. So now we are going to talk about process synchronization methods. So there are two, there are two types of communication. First are blocking, and second are non-blocking. And blocking also have two subsets, which is one is blocking send and one is blocking process. I mean, sorry, blocking receive. A blocking send, a process pauses until the message is received. And a blocking receive, a process waits. It waits until it gets a message. Okay? And then we have non-blocking, which is asynchronous communication. So non-blocking send, a process sends the message freely, even if other have not received them. Okay? Non-blocking receive, a process can accept message immediately without waiting. So this non-blocking a process accept message immediately without waiting. Okay? Yeah. So that is blocking and non-blocking. So next we are going to talk about deadlock. So what is a deadlock? A deadlock is a situation where two or more processes wait for each other indefinitely, like a traffic jam where a car refuses to move. So deadlock condition for it to occur is mutual exclusion. Only one process can as a resource at a time. So and hold and wait. Process keep resource while waiting for a new ones. No preemption. No preemption. Resource cannot be forcibly taken from a process. Circular waiting and I'm sorry. Resource cannot be forcibly taken from a process. That's circular waiting. A chain of process is waiting for each other, creating a loop. Okay. Now let's focus on the picture. So this here, there is no deadlock yet because one data, one process. Same as this, one data, one process. Same as this, G, one data, one process. H is also one data, one process. Okay. Uh, so S requests A, and then A requests R. Okay. So there is no deadlock yet. I is also the same. It is actually there's no deadlock yet. Deadlock occurs when it comes to here, diagram J. I mean, yeah, diagram J. So this is when a two process, this is what it means by two process at the same time, okay? So R with C and T with C. So this occur, this a deadlock will occur. And when that happens, it will stuck, the system will stuck waiting for a command from others I, and it cannot, just like a traffic jam where, yeah, a traffic jam when the car refuses to move, right? So this is the same thing. So there it is. That is the deadlock, and I hope you guys understand. And yeah, thank you very much.